Hi folks, it's Mr. Robeson here. We're back with confidence intervals. Now we are doing them for mean. So we're going to take a look at what a z-interval looks like for mean. We're going to talk about what t-distributions are. Then we're going to talk about one sample t-intervals for mean. All right, and we're going to go over how to find those t-values. All right, so confidence intervals for mean when the standard deviation of the population is known. So again, this is the symbol for population. And if you notice, hopefully you noticed this is not on the AAP exam. I just wanted to show it to you because this is like the analog of what we're doing with the proportions right now. So with proportions, we're using Z star here as our critical value. So remember, our critical value has to do with our confidence level. All right, well, we can do that also with mean, but we only do that with mean if we know the population standard deviation. Chances are we do not know that information. If we knew the population standard deviation, then we automatically already must have known the population mean. All right, so then using a sample mean to predict the population mean would kind of be a moot point. We wouldn't have to do that. All right, so this is called a one sample z-interval for population mean, or for mu if you want. It is built into your calculator. It is called z-interval. All right, but again, you should not be using this on the AP exam. I just wanted to show it to you because, you know, it's one of the things that's there on the calculator, and I always get asked about it every year. So a farmer wants to estimate the mean weight of tomatoes grown on his farm. To do so, he selects a random sample of 40 tomatoes. There's an N, 40. Finds X bar equal to 120 grams. So that is the mean tomato weight of his sample. He knows the tomato weights are normally distributed. Cool, that usually helps us with our normal conditions. And have a standard deviation of 20 grams. All right, so he's talking about the population. He knows the tomato weights are normally distributed and usually have a standard deviation of 20 grams. Again, this will not be a case on the AP exam. Calculated 90% confidence interval. All right, so we would just take these numbers and we would plug it into z-interval. So we pull out our calculator. We go to stat, test, and we're looking for z-interval because we know the population standard deviation. And we're dealing with, these are statistics here, so we're dealing with those. And we're just going to type those in. I think they're already here. So our population standard deviation was 20. Our sample mean is 120. Our sample size is 40. Our confidence level is 90%, which would be 0.9. And we click calculate, and there we go. 114.8 to 125.2. All right, so that would be how we would do that. But again, we're not going to do that. We are instead going to use the t-distribution, and we're going to work with t stars instead of z stars. All right. So when we don't know the population standard deviation, we have to use the sample standard deviation. Now, if we use the sample standard deviation and we try and make these intervals, it doesn't quite work if we use z-distributions. All right, so what they did is mathematicians went and they worked it out and they found these other distributions called t-distributions, or sometimes called students' t-distributions, because when it was originally published, the paper was written as by a student. All right. And these t-distributions depend on the sample size, or what we call the degrees of freedom. So n is your sample size. So each one of these t-distributions is dependent on n minus 1, the sample size minus 1. All right, so as you can see here with df, degrees of freedom being 1, here's your smallest or most spread out distribution. And as the df gets higher and higher, like your sample size gets bigger and bigger, it approaches this dotted line here, which is the normal distribution. So it is very close to a normal distribution, but it's not exactly the same as a normal distribution. All right, so here's the actual function we use, or your calculator is using when you're working with z. This is the normal distribution. This gives you the nice looking graph that looks something like that. This monstrosity over here is how they come up with a t-distribution. All right, now this is the gamma function. Like, we're not going to go over that at all. We're dealing with integrals and calculus and factorials and all sorts of stuff. All right, it's really, really ugly. This is just this is just exponential. This is much, much harder. So we're not dealing with the actual distribution. It's always just going to be built into the calculator. All right, so this is how our confidence intervals work when we don't have the population standard deviation, but when we have the sample standard deviation, which we can always find. So if we're taking a sample, we can find the sample standard deviation. So then we use the t star instead of z star, in which reminds us we can use the phrase zap tax to remember this. So we use z's when we're working with p's, and we use t's when we're working with means. Sample mean, tax, x, yeah. Tax tam doesn't really sound the same. All right, but we are going to have to write down what our degrees of freedom are, and we're going to have to be able to calculate those t stars. So just like last time, this whole side over here, the t star times the standard deviation of the sampling distribution, Sx, I guess it's the standard error, not necessarily the standard deviation of the sampling distribution, the standard error, because we don't have the population standard deviation. This is our margin of error, just like before. Sometimes we just call that ME or MOE. And our standard error of x bar is the standard deviation of the sample divided by the square root of n. I guess the question should come up now is, how do we find t star? We know we can find z star with inverse norm. Well, built into your calculator is an inverse t operation. All right, there's also, like, we have normal CDF and normal PDF, or CDF is always the one we use with normal. Well, we also have a t CDF, so that's also there too. So like if we want to work with a t distribution like we work with a normal distribution, we can do that right here. I don't know if I'd give you any problems with that, but inverse norm is more likely to be the one you use. And once you go to, inverse t. And once you go to inverse t, you're going to find like the confidence level. We're going to use that to find how much is left over in the ends. Your degrees of freedom is going to be n minus 1, and you're just going to paste. All right, we got two examples here. So find the critical value for a 90% confidence interval for the mean with a sample size of 20. All right, so we've got n is 20. So that means our degrees of freedom is 19. 20 minus 1. All right, we're trying to use mean. So that tells us we're working with x bar. Our confidence level is 90%. So if we draw a sketch of this, which I suggest doing, it does help. All right, and it does look just like a normal curve. There's no way I can draw it by hand differently. Here's 90% for our confidence interval. All right, so these are what we're going to find. All right, which means we've got 10% left over. So like 1 minus the 0.90 gives us the 10% left over. And we divide it evenly between the two ends, just like before, and we get 5% in each end. All right, that's where I'm getting this number. 1 minus the c divided by 2. That's how we get what's in the tail. So now we're doing inverse t. The area is 0.05, and the degrees of freedom is 19. And we just go to our calculator, and we're just going to type that in. So second distribution menu, inverse t, because we're working with t distributions now. The area is 0.05. The degrees of freedom is 19. And we get, there it is. So on this end is the negative 1.729. Negative 1.729. And this one will just be the positive 1.729. So our t star would be plus or minus, I guess, 1.729. And that's what we would use to make our margin of error. All right, now there's no use trying to memorize these because it changes for every degrees of freedom value. Right? So we use 90% a lot, but every DF has a different one, different answer. So no point in doing that. Let's try one more. 95%, we're working with the mean, and the sample size is now 10. So if our n is 10, that means our degrees of freedom is 9. Our confidence level is 95% or 0.95. So that means we've got now 95% in the middle, which leaves us with 5% to split between the two ends. So this is going to be 0.025, 2.5%, 0.025, another 2.5%. So into our inverse t, we put our area of this 0.025, and our degrees of freedom, we put in the 9. So second distribution, inverse t, there it is, 0.025, not 0.25, and 9. And we get negative 2.262. 262, and this would be positive 2.262. So that is our t star that we would use, plus or minus 2.262. All right, so that's the first video. So that's how we work with t distributions and find our one sample t intervals. I guess we haven't found the interval yet, but we're mostly going to use the calculator for that. But now we know how to find the t's.